In lesson 1.8, we're going to be talking about regular polygons versus irregular polygons. We're going to talk about polygons and symmetry and inscribing a hexagon into a circle. So those are the three things we're going to talk about today. So first, let's start talking about regular polygons versus irregular polygons. We already learned what a polygon is and what it's not. We know that polygons have straight sides, we know that polygons are closed, and polygons, the sides of polygons do not intersect. So today let's talk about regular ones and irregular ones. So first let's draw some and see if you can notice the difference. So here we have a regular 1, 2, 3, 4, 5. A regular pentagon. You've seen that before. Now here let's draw an irregular pentagon. 1, 2, 3, 4, 5. Okay, this would be an irregular pentagon. It also has 1, 2, 3, 4, 5 sides, but it's an irregular pentagon. Here let's draw a regular hexagon. 1, 2, 3, 4, 5, 6. And here let's draw an irregular hexagon. 1, 2, 3, 4, 5, and well, let me make that better looking. There we go. 1, 2, 3, 4, 5, 6. An irregular hexagon. Okay. And finally, let's try something a little bit tricky. Let's try an octagon. Regular octagon. 1, 2, 3, 4, 5, 6, 7, 8. And here's an irregular octagon. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are all considered polygons because they are closed, because they have straight sides, and because their sides do not intersect. So these are all considered polygons. However, these are considered regular polygons over here, and these are considered irregular polygons. What's the difference between a regular polygon and an irregular polygon? So take a second and look at these, right? Regular pentagon, regular octagon, regular hexagon, irregular pentagon, irregular hexagon, irregular octagon. What makes a polygon regular, like these? What makes a polygon irregular? Well, the answer is regular polygons are the way that you see them all the time. They're familiar. It's the shape. When we say pentagon, it's the image that everyone sees. A regular hexagon is the hexagon that we all know. A regular octagon is the octagon that we all know and that we can all close our eyes and see. An irregular octagon, it's still an octagon, but they look different. An irregular pentagon, it's still a pentagon, but it looks different. And an irregular hexagon is a hexagon that looks different. So now let's move on to polygons and symmetry. So let's draw some polygons. So here let's draw a square, quick sketch. Here let's draw a rectangle. Whoops, that's not a very nice looking rectangle. Here let's draw a rectangle. Here let's draw another quadrilateral, the trapezoid. Okay. Here let's draw, let's say, a pentagon. Okay, so a line of symmetry is any line where we can fold our shape and both sides will be the same. So if you look at a rectangle, if I drew a line here, you notice that this side over here would be the same as this side over here. So this line right here would be considered a line of symmetry. Okay, now some shapes have one line, some have zero, some have many. So let's try a different one. If I drew a line here, let's draw a dotted line right here. Would this be considered a line of symmetry? Well, if you said no, you'd be correct because this part is not the same as that part. Okay, let's try a different line. Okay, let's try. Okay, so the rectangle, with a rectangle, that is considered a line of symmetry, and is this considered a line of symmetry? Okay, this is also considered a line of symmetry because the top portion is the same size as the bottom portion, and not only are they the same size, but if you fold it, this green portion would fold right on top of this portion, right? Let's call this corner A, B, C, and D. If you folded it, A would fold right on top of D, and B would fold right on top of C, if we could fold it there, right? Now, be careful. It seems easy, but here's a mistake that something a lot of people have a hard time with. So let's look at this diagonal. Would that be considered a line of symmetry? Okay, this is something that a lot of people struggle with. So let's look. If we folded this, right, if we folded on this line, would A fold right on top of D? Would B fold right on top of C? No, it wouldn't. And that's why that diagonal is not a line of symmetry. Because when you take a rectangle piece of paper and if you fold it on the diagonal, you'll notice that this corner, right, does not fold on top of this corner. If you fold it along the diagonal, it actually looks something like this. And therefore, on a rectangle, the diagonal in a rectangle is not a line of symmetry. Okay, so what about a square? How many lines of symmetry does a square have? Let's see. Take a second to think about it. Okay, so if you said 1, 2, 3, 4, you'd be correct. A square has 4 lines of symmetry. Now let's look at the trapezoid. Okay, on the trapezoid, is this a line of symmetry? It is, because corner C would fold right on top onto corner D, and corner B, this vertex, would fold right on top of that vertex. Okay, so that is a line of symmetry. However, let's fix our polygon. Let's close it. Is this a line of symmetry? No, it's not, because if we folded it there, A would fold down here, and B would end up somewhere here. It would not fold on top of itself, so that is not a line of symmetry. All right, this brings us up to our final point. How can we inscribe a hexagon into a circle? So yesterday we learned about using a compass. So today we're going to use our compass again, and we're going to draw a circle. Okay. Remember, you could turn the handle or you could turn the paper. Okay. Now, after you've made your circle, I'm just going to trace this so you can see it in marker a little bit better. Okay, remember what we talked about earlier, that where the anchor was, this is known as my center. Okay, so now what I could do is I could take my compass and I can try to make, I can try to make 6 points that are about the same length. Okay, so let me make 1 point here, and then I'll make 1 point straight across from it here, and I'll make another one there. Now I'm going to try to make 6 more points. This is going to be point 1 over 1. Okay, let me try to make 6 more points, about the same. Okay. All right, this could be a little bit tricky. Let's make about 6 more points. All right, so this is point number 1, number 2, number 3, number 4, number 5, number 6. Now I'm going to connect these points. So I'm going to use my ruler to connect this. Do you remember what that's called in geometry? When a line goes from the outside of the circle to the outside of the circle, but does not go through the center. Well, if you said chord, you'd be right. That's a chord. So now let's make 5 more chords. Okay. Okay. Now we've got 5 chords. Well, we've got 6 chords, and we've inscribed a hexagon inside of our circle. Okay. Now what we can do is we could take a different one, and we could connect opposite points on our circle. And we can connect those. It'll go through the center to this point. And now what have we made? Okay, we learned about that in an early lesson. That's the diameter. It goes from one side to the other and through the center. Let's connect opposite points, points 1 and 4. And again, we'll go through the center, and we have another diameter. Let's connect points 2 and 5 and go through the center, and we have another diameter. Okay? And what we've done is we've inscribed a hexagon, a blue hexagon, into our circle, and we've also inscribed triangles, 6 triangles, into our circle. Good luck.